This is the lesson for Chapter 6, Section 2, titled Solving Systems Using Substitutions. Let's take a look at our first problem here, and it says 4y equals x. And so what we're going to end up doing is taking this expression that x is and substituting it in place of x into the other equation. So I'm going to rewrite that other equation, 3, but in place of x I'm going to write 4y because that's what x is. And then minus the y equals 70. So I go ahead and use some multiplication here. Multiply 3 and 4 makes 12y minus y equals 70. So I go ahead and do a little more work, and I've now got 11y equals 70. So in this case, when I divide, 11 doesn't go in there quite evenly, and that's okay. Sometimes that happens, sometimes it doesn't. But I see that 11 does go in there 6 times with that makes 66, so I'll have 4 left over. So I've got 6 and 4 elevenths. And so I go ahead and find out what y is. Now here's where I'm going to use the improper fraction form, because when I go ahead and substitute, I'm going to have to multiply. So I have 4y equals x. So when I go ahead and rewrite this, instead of writing the mixed number form, I'm going to write the 70 elevenths. So no cross canceling. So I just multiply across, and that makes 280 elevenths. And so if I was to change that to a mixed number, that ends up becoming 25 and 5 elevenths. So my answer is an ordered pair. It's where the two lines cross. And so my first number here, I'll write the 25 actually first. 25 and 5 elevenths. And then comma 6 and 4 elevenths. So this is where the two lines will cross. Here's a perfect example of why you wouldn't want to use graphing to solve this problem, because you're probably not going to find out exactly what that is, since the points are fractions, first of all, or mixed numbers, and they're so far apart. Looking at this next problem, I don't have x solved for, I've got y solved for. So I'm going to take that expression that y is this time and put it in place of y in the other equation. So I'm going to rewrite this as negative 2x plus 5. Now, y is 3x minus 4, so that's what I put in place of that y, and this all equals 19. So when I go ahead and do some work, I've got negative 2x plus 15x minus 20. Minus 20 equals 19. So I go ahead and do a little work here. This makes 13x. I'll add the 20 to both sides, and so when I do that, I end up with 39. And fortunately, 13 does go into 39. It goes in there 3 times. And so x is 3. So to find out what y is, well, I've got a choice. I could substitute into the first equation or the second equation. And I think it's easier to substitute it into that second equation because y is already solved for. So it's just 3 times 3 minus 4. So I multiply first. I got 9. And 9 minus 4 makes 5. So 5 and 3. So this is an ordered pair. 3, 5. That's where the two lines cross. Well, looking at the next problem, here I have a problem in which I've got negative 2x plus y equals negative 1, and 4x plus 2y equals 12. So I don't have a variable solved for. So I have to get a variable by itself. So a few different choices here. In this case, it's easiest to solve for this y of this top equation. So I'm going to just rewrite it. And I'm going to add the 2x to both sides here. And so when I rewrite that, y is now by itself. Y equals 2x minus 1. And so when I go ahead and now I can substitute into the other equation, put that 2x minus 1 in place of that y in that top equation. So I now have 4x plus 2 times by 2x minus 1. And this all equals 12. So I'll go ahead and distribute. And I've got this, 4x plus 4x minus 2 equals 12. And when I go ahead and solve, I'll add the 2 to all sides. And when I do that, now I have 8x equals 14. So in this case, I got another case in which we don't have an actual answer here, because we see that the 8 doesn't quite go into 14. So I'm just going to rewrite that as x equals 7/4. I got that by dividing each of these two terms by 2. And so if I want to change that to a mixed number or a decimal form, that would be almost 2. So it would be 1 3/4, or 1.75. So now I'm going to find my y value. I'm going to substitute back into that modified equation, 2 times by 7/4 and then minus the 1. So again, I always use the improper fraction form instead of the mixed number form because that's what you have to do when you multiply mixed numbers, is change them into improper fractions. So I got to subtract 1 from 14/4. So I'm going to take that 1 and change it to 4/4. That's the same thing as 1. And so when I do that subtraction, I end up with 10/4, which is, when I take out the common factor of 2, 5/2, so 2.5. So my point is, my value in which they cross, the two lines cross, is my x value and my y value. That's where the point of intersection, and that would end up being 1 3/4, comma, and again this is the same thing as 2 1/2, so that's what I'm going to write for the y value. So those are some examples of just regular equations, solving for those. Let's take a look at some word problems. So first one here says, a snack bar sells 2 sizes of snack packs. Okay, so 2 sizes. This is probably going to be our 2 unknowns, or 2 different sizes. So we're going to have a large snack pack that is $5, and we have a small snack pack that is $3. One day the snack bar sold 60 snack packs for a total of 220. So we know the 2 different types, the large and the small, combined to make 60. And so what we want to do is we want to find out how many small snack packs they sold. So just the small ones. So let's try writing some equations. First thing we need to do is define some variables. It's nice to be able to use the letters that correspond to the word that we're trying to find. So we're going to use L for the number of large snack packs, and we're going to end up using S equals the number of small snack packs. Alright, so from this point, let's go ahead and try to write an equation. So we're going to have 2 different equations. I call the first one the quantity equation. It's a quantity equation because it's asking how many we have. L plus S equals 60 snack packs is what we end up selling. So the number of large plus the number of small equals a total number of 60. And then I have what I call a value equation. Value is, in this case, dollars, and it is $220. So it's the price of a large, $5, times the number of larges we bought, plus the price of a small, which is $3, times the number of smalls that we sold. And total is $220. So now I've got a system of equations, so now we have to solve. So first thing using substitution is to get one of these variables by itself. Now since we want to solve for the small snack packs, we're going to end up solving not for S, but for L. So I'm going to move that S over to the other side, and actually I take that back. Let's see here. We'll we're going to end up solving for L, that's right, because we want to keep the S in the problem. So I'll subtract the S from both sides, and I now have this, 60 minus S. So now I'm going to take that expression and substitute in place of the S, or in place of the L, right, in that spot. So I'm going to rewrite this as 5 times by 60 minus S, and then plus the 3S, equals 220. So I go ahead and distribute, and I've now got 300 and minus 5s plus 3s equals 220. So I go ahead and do some opposite operations. I'll subtract the 300, leaves me with a negative 80. And this all equals negative 2s. So now we have to divide by negative 2, and we get s equals 40. So it's 40 small snack packs. Small snack packs is the amount that we ended up selling that time. So let's take a look at another problem, very similar. It talks about a talent show. In a talent show, we have singing and comedy acts. And the singing acts are 5 minutes. And comedy acts, well, those are 3 minutes. And the show has a total of 12 acts, which last for 15 minutes. So we'll start with the we'll start with writing down a listing of our variables. We'll say S equals the number of singing acts, and then we'll say that C equals the number of comedy acts. And so from there, we can go ahead and try to write an equation. We're going to do the same sort of thing. We've got our quantity equation, and we've got a value. Now, the value this time deals with not with money, but with minutes. Sometimes minutes are valuable also, and so that's what we're going to end up using for our value. So the quantity is the number of singing acts plus the number of comedy acts, and there's 12 altogether. The value is the amount of minutes. So we have 5 minutes for the singing acts, 3 minutes for the comedy acts, and there were a total of 50 minutes altogether. So same sort of thing. This time they want to know how many singing acts and how many comedy acts. They want to know both. So it doesn't matter which one we solve for in this case. So I'm going to just go ahead and solve for S. So if I do that, I end up subtracting the C, so I have 12 minus C. And so then I'll go ahead and substitute that back in place of this S right here. And so I'm going to rewrite 5, and in place of S, I'm going to write down the 12 minus C, and then plus the 3C equals 50. And so from that point, I can go ahead and distribute, and I've got 60 minus 5C plus 3C equals 50. And I'll go ahead and do some opposite operations, subtracting 60 from all sides. And I'm left with a 2C, and negative 2C equals negative 10. So when I do that division, I see I get C equals 5. So there's 5 comedy acts, and we also have to find the number of singing acts. Well, we can just plug into the quantity equations, the quickest one. So you see how we have S plus 5 equals 12. So that tells me S equals 7 when I do that subtraction. So 7 singing acts. So those are the types of problems you're going to see on tonight's homework. Good luck.